Today we have Duncan Watts, Principal Researcher at Microsoft Research in New York. Duncan is one of the world's leading figures working in networks at the intersection of information science and social sciences. We are very pleased to have him visiting Cambridge for a week. So Duncan, let's start at the beginning. How did you get thinking about small worlds?
No, it was a funny sort of trajectory. I was at the time doing my PhD in an engineering department called Theoretical and Applied Mechanics, which actually doesn't exist anymore. That Cornell got rid of that department. But my advisor was Steve Strogatz, who is an applied mathematician, and his specialty, which is the reason I had gone to study at Cornell, was coupled oscillators, the synchronization of coupled oscillators. And so he and I were working on this project where we were trying to understand how populations of crickets could synchronize their chirps. And it turns out that this particular species of cricket, the snowy tree cricket, is a native of upstate New York, including Cornell's campus. And so these crickets were actually, during the late summer, would come out of their they would hatch, and then they would start chirping in the evenings. And so I was working on this project with Steve and an entomologist, Tim Forrest, and Tim and I would go and clamber around in the trees on Cornell's campus and try and catch these crickets. And I would put them in a soundproof chamber, and then I would sort of chirp at them with a computer and try to manipulate their chirping to understand how they were responding to each other, because there was this whole sort of mathematical theory of phase response oscillators, or phase coupled oscillators, that we were trying to prove. But while I was doing all of this work with crickets, I was sitting there for hours and hours and hours on end in the middle of the night trying to get these little creatures to chirp at me, and I started thinking about how they were connected to each other. That you have this sort of tree full of crickets, and quite large trees and over long distances, and somehow they're communicating with each other and they're responding to each other. And so you sort of can imagine in your mind's eye that there is some kind of network connecting them, where they're not all listening to everybody equally. Maybe they're listening to sort of their sort of spatially proximate neighbors. But there's all sorts of things in the way and complications, and so you can sort of imagine that there's some kind of somewhat complicated network connecting these crickets. And I started to sort of wonder about, well, how would you describe this network mathematically, and what kinds of properties would it have, and what do those properties? How would those properties govern the ability of these creatures to synchronize? And so I was sort of thinking about that problem, and then at the same time, I had this somewhat random conversation with my father on the phone one day. I would call home to Australia and talk to my parents about what I was doing. And one day on the phone, he said, "Have you ever heard of this myth or this piece of folklore that everyone in the world is connected to the President of the United States by six handshakes?" And I actually hadn't heard of it, and I thought it was a very intriguing idea. That you're shaking hands with someone who's shaking hands with someone who's shaking hands with someone who's shaking hands with the President of the United States, and everybody in the world can make this claim through just 6 handshakes. So this is sort of the claim. This is a very famous idea now. We call it 6 degrees of separation. But back in the mid-1990s, this was not something that everybody had heard of. And even if you had heard of it, it was sort of expressed more as a sort of piece of folklore or a myth than actual science. And so I had these sort of 2 ideas that I was thinking about. One about the structure of social networks, and the other about the structure of communication networks. And I began to wonder if there was something in common with these 2 problems. And I thought, can we start to write down some mathematical principles about the structure of networks and the relationship between the structure of networks and their dynamical properties. And so this of course, has very, very broad implications, not just sort of cricket synchronizing, but thinking about how information spreads through large social networks, how diseases spread through networks of physical contact, how large organizations process information, how financial markets demonstrate contagion, even how cells in the brain or in your body communicate with each other. And all of these systems have network properties, and in all of them you might think that somehow those properties are relevant to the sorts of dynamical questions that we care about in social science and also in biological sciences and engineering. And so that's where this idea of small world networks came from, that I was trying to figure out if this claim that everyone is connected by just 6 handshakes was actually true, and whether it was just true of social networks or whether it was true of all networks. And actually what Steve and I ended up demonstrating was that it was probably true of all networks. And so this is sort of where this whole idea of small world networks came from.
But of course it had, when you started writing this up and in your book, etc., it became clear that there was earlier old work in random graph theory, which had some of these features but not other features. So there was more to the story. The plot thickens.
Yes. No. So we were sort of we sort of did what you're not supposed to do in academic life, which is just sort of go off on your own and think about a problem. You're supposed to sort of do your homework. We didn't actually know really what homework we were supposed to do. We did know about the theory of random graphs that comes from Erdős and Renyi back in the 1950s. But the whole point of random graphs is that they're random, right? That you're sort of choosing. If you imagine, what would a random graph of friendships look like? Imagine, if everybody in the world, let's say, has 300 friends. This is sort of typical. If you look at Facebook now, the typical number of friends is about 300. So let's say everybody has 300 friends. So I pick 300 friends randomly for the population of the entire planet, from out of 6 billion people. And so the chances of me being friends with anybody in Cambridge is essentially 0. Because, 1/3 of all my friends will be from China. Or 1/6 will be from China, and 1/3 will be from, most will be from countries that I've never even visited. And then every one of those 300 people would pick their friends at random from the population of the entire planet. And of course, this is a completely ridiculous model. Like we know that social networks are almost at the opposite extreme, where we have friends that we know from growing up, we have friends that we know from going to school, we have friends that we know from work. And so the vast majority of our friends are determined by a relatively small number of sort of socially relevant contexts that we've spent most of our lives in. And many of our friends are also friends with each other, for much the same reason. So when sociologists study social networks, they observe this property called homophily, that people who are friends are much, much more similar to each other than people who are not friends. And so there's this whole sort of theory of random graphs, from which you can prove that everybody in a random graph is connected by a relatively short path to everybody else. But we also know that random graphs are a very, very poor description of actual social networks. Because social networks are characterized by sort of this opposite feature, which is that you have a lot of local order, which is the opposite of randomness. And so really what Steve and I were trying to do was marry up these two kind of views of the world, that there's a lot of local order, and then what we did was allow there to be sort of an increasing amount of randomness in the network, so that you could have a network that had lots and lots of this clustering, where your friends are friends with each other. And then you introduce just a little bit of randomness to, sort of allow for the occasional sort of serendipitous event in your life where, for example, maybe you move countries to go to school or something, or you sit on a plane and you meet some strange person and you form a new friendship. These are the events that are not constrained by the sort of social context that you spend most of your life in. And so we could show that just by introducing a very, very tiny fraction of these random links into a network, you essentially get this property that you see in random graphs, which is that everybody is connected through these. And you have the local structure. and you have the local structure. Yeah. So yeah, so there was this sort of long history of random graph theory that we were sort of drawing upon, but we were almost starting from the other end of the spectrum, where we were saying things are very, very ordered, and then we just introduce a little bit of randomness.
So one thing I wanted to get a sense from you, how do you, and I see this in your work over time now, you have theory, but you also have experiments increasingly, and you work with very large data sets.
Yeah.
So how does this happen?
I think it's partly, you know, a function of my own predispositions that I'm very interested in how these sort of theories play out in the real world. So I am very concerned with, you know, the empirical relevance of theory. But the other thing that happened, and maybe was the driving force, even more of a driving force, was that the world changed. Right, that, you know, back in the late 1990s, when, you know, Strogatz and I started working on these network models, there really wasn't any large-scale network data available. Right, that, you know, and sociologists had been doing network analysis for decades at that point.
Oh,
and,
yes, maybe for 50 years.
And we became aware of that work sort of relatively late in you know, in my PhD, but that was a very interesting community that I, you know, essentially ended up joining, because I went and taught sociology at Columbia for several years. And my postdoc advisor was Harrison White, who was one of the sort of, you know, great figures in network analysis from particularly from the 1970s. But, you know, the data that they had available to them was, you know, probably on the order of, you know, at most a couple of hundred people in a network. And the reason why they were limited in that way is because in order to collect network data, they had to go out and conduct surveys. So they would have to, you know, hand out literally pieces of paper to people in some organization, a business firm or a social group, and ask them to fill out, you know, who their friends were, and who their, in some cases, who they didn't like and who they went to for advice. And these were called network generators. But just the sheer manual nature of doing this meant that you know, that you couldn't do it, you know, over long periods of time or for very large groups. And this began to change around in the late 1990s, that as the web became prevalent. And by the way, the web itself sort of provided a concrete instantiation of this network metaphor, that, you know, people started to think about networks more because of the web and because of globalization and all these other sort of things that were happening around us, that it was sort of in the air to think about networks. And then the web itself started to generate data at an enormous rate. And so, you know, over the years, we sort of went from a fairly sort of data poor environment where we could think about networks theoretically, and we could write down these simple mathematical models, and we could simulate them in computers, but there wasn't a lot of data to actually compare the output to. And then, you know, a handful of years later, you know, we have, you know, Friendster, and then we have Facebook, and then we have Twitter, and then we have, you know, sort of networks of 1 billion people, which is, you know, roughly the size of Facebook these days.
Yes.
Which was absolutely inconceivable back in the late 1990s. There was no way that in my mind, that we could ever have a network of 1 billion people in which everybody had declared their friendships with everyone else. And yet this is basically what Facebook is today. It's not perfect, but it is over 1 billion people, and it's reasonably comprehensive in terms of people naming their friends. So simply because it was possible to now do you know, empirical work with large data sets, we started to do that. And then, you know, even more recently, we've been, as you just mentioned, we've been doing experiments where we use the web as a sort of virtual laboratory. And so, you know, instead of the 20th century model where often psychologists and then more recently economists would bring, you know, undergraduate students into the lab and you know with a few at a time, and conduct some experiment where they would, you know, do something about learning or perception or whatever. Now we can do that online, and we can bring, you know, hundreds or possibly even thousands of people together in a lab-like environment and study potentially how the structure of networks affects the way that they cooperate with each other, or how information spreads through networks, how people solve problems. And we can do that in a way where we can manipulate their conditions experimentally. So the web has done a couple of things for social science. One is that by virtue of people using all of these new technologies like email, like social networking services, even user-generated content online, it's spewing off a vast amount of data that social scientists and increasingly computer scientists can use to study or shed light on these often quite old questions of social science. And it's also giving us the platforms to be able to do experiments on a scale that would have been previously unimaginable. So in some sense, I've really just been sort of following the path of, I wouldn't say the path of least resistance, it might be the path of most resistance, but in some sense I'm sort of tracking what's possible. And when we could only do theory, we did theory, and when we can do experiments, we do experiments, and that's really what's been driving it.
But some of your work that I enjoy the most is more behavioral. It's actually, you could think of it as networks in some sort of meta sense, but it's sort of this experiment on downloads of music and so on. How did you get into that? Because that's sort of also relating to experiments, I guess. So how did it happen? Because
well, I had been doing some theoretical work, modeling diffusion on networks, and I had sort of stumbled on this, I thought, very interesting finding where, so in this model, this theoretical model, you have a large network, in this case a random network, so it wasn't very realistic. It was the simplest thing I could think of. And everybody in this network has some probability of adopting the new thing. And their probability of adopting is basically a threshold function. It's when a certain fraction of my neighbors adopts, I'll adopt, otherwise I won't adopt. So this is an old model, it goes back to Mark Granovetter in the 1970s.
This is the threshold model.
This is the threshold model. And there are similar models in economics.
The Schelling also had some work.
Schelling, even before Granovetter, exactly. So very similar to the Schelling model, except now it's on a network, right? And so there was there were a couple of interesting results that came out of this analysis. But the one that I found most provocative was that when you're in a particular region of the network space, you can have a network that looks very, very stable, and you can be pinging away at it and introducing shocks into the network, and nothing really spreads. And then all of a sudden, you don't really change anything. You just randomly pick a different node, and the entire network lights up. And I was thinking, if you were watching this, you would suddenly see this huge event happen. You see nothing happening, nothing happening, nothing happening. Huge event happens, and you would think, something special happened then. What was going on? And you would, if you were an historian, you would sort of go digging back into the past, and you would find this person had begun this thing, and you would say, this person is a really special person, or their idea must have been really, really fantastic because it's the one that succeeded, not all the other ones. But of course, by construction, we know this isn't true, that it's just exactly the same as everything else. This person is not special, the idea is not special. It's just this 1 in 1,000 event that suddenly takes off. And so it really sort of changes how you think about our interpretation of history. If the things that we regard as special are in some sense just accidents. And of course you can make this point using these theoretical models, but it's very hard. Actually, people just don't like this answer, basically.
Well, it can be done in a model, but who cares?
Right. So they say this is not real. Just because you show this in the model doesn't mean that the Mona Lisa is an accident of history, or that Harry Potter is an accident of history, or any of these things that I personally believe are special and unique are just accidents. They were always special and unique, and it just took the world a while to figure it out. And so that was what prompted the idea of doing an experiment, because you can do these sort of theoretical models till you go blue in the face, and people will just say, well, you made a whole bunch of assumptions in your model, and one of those assumptions is wrong. And I didn't even have to figure out which one it is, because I just don't believe the answer. But if you do an experiment, experiments are also problematic in that things are different in the lab than they are in the real world, but at least you're dealing with real people and they're making real decisions. And so
and you
I
can
felt,
control things enough to identify.
Things, yes, and you can do that with simulations too. But the experiment is just more. It seems I thought sort of it would be more persuasive to people that if you could show this same effect happening in a real live laboratory setting with real people making real decisions about real things like music in this case, that it would be able to reinforce this point more effectively, and also we were trying to explore the capability for the web to run these very large virtual lab experiments. So we came up with this idea. Matt Salganic, who was my grad student at the time, now a sociology professor at Princeton and a visiting researcher at Microsoft, and Peter Dodds, who was a postdoc working with me at the time and now is a professor at Vermont. We built this thing called Music Lab, where we constructed this sort of fake download site where you could come and listen to 48 different songs by bands that no one had ever heard of. And some people who visited the site got to see how many times the songs had been downloaded by people before them, and other people didn't get that information. So they were forced to make independent decisions. And by randomly assigning arrivals to one of these two conditions, we could effectively measure the effect of information, of this social influence. And what we found using about 30,000 people, so a huge number of people, compared to a standard laboratory experiment where maybe you'd have 100. We're able to show that when people know what other people like, popular things become more popular and unpopular things become less popular relative to the condition where people are making decisions independently. And at the same time, it becomes increasingly difficult to predict which particular thing is going to become the most popular. So it was this sort of simultaneous increase in both inequality and unpredictability that was sort of the core result. And if you understand these mathematical models very well, you might not find that result very surprising because that's basically what the models predict. But if you're anybody else, which is the vast majority of the world's population who do not understand these mathematical models very well, it's a really big surprising result because we were very used to this common sense notion that success and quality are very closely linked, that the things that succeed because they're better than the things that don't succeed. You know, they worked harder, they had talent, they were original, it's something. They must have had something, otherwise why are they so successful? It just, you know, maybe you don't like Madonna, but you believe that the world likes Madonna, right? That she is somehow, you know, her success reveals the preferences of the market.
Right.
And what we showed in this experiment is that markets don't just reveal preferences, they also construct them.
Yes.
And this is where this sort of inextricable unpredictability comes from, is the market is actually creating its own demand.
What you're showing in this experiment is that these preferences themselves are actually, there's nothing stable about these preferences. They're very malleable, they're very vulnerable to influence, if you like. So is this also, you know, a major motivation for your new book?
Well, it's funny that, so this notion that preferences are primitives, you know, is I think it's a very common sense notion. You know, and economists will dress it up in lots of fancy mathematical terminology, but at the end of the day, everyone would agree with that statement, right? I mean, it's just except a psychologist, right, who actually studies, you know, preference formation. You know, most people would say, sure, I know what I like. You know, like I know my own mind. Don't tell me that I don't know my own mind. You know, I know I prefer this to that. I know what's good. You know, so it's a very sort of, you know, people, you know, this is an ancient, or at least, you know, going back to the Enlightenment, this idea that, you know your own mind, right? That you are, you know, that you're in control of things, that you possess agency. So these are very widely shared notions of human behavior and what I would describe as common sense notions. And so you might think, sure, you know, I'll listen to what my friends tell me. You know, maybe I'm maybe I trust my friends' recommendations because they know what I like. So yeah, I'll admit that I'm influenced a little bit by other people. But we sort of see this as sort of a small, order epsilon effect compared to the primary, first order effect, which is my intrinsic preferences. And really what experiments like Music Lab show is that, it actually, this influence effect is much bigger than we're comfortable admitting. And there's a couple of reasons for it. It's not necessarily because you're actually changing my mind. It may just be because you're exposing me preferentially to some information rather than others, right? That the world is far too large and complicated for us to ever sort of systematically go and form preferences about everything, right? If you walk into a bookstore, there's tens of thousands of books in there. You can't actually rank all those books in your mind, right? You'll never even get the opportunity to. And then, Amazon has millions of books and there's tens of millions of songs in the world. So it's sort of, as a theoretical exercise, you might say, if I were able to go through and listen to all these songs, I might have preferences over them. But in reality, you're never going to do that. And so you're going to be exposed to some small subset of that, of the whole world, and that will determine what you like. Because even if you're not actually having your preferences, your sort of internal preferences modified, your revealed preferences will be modified. But I also do think that there is an element of persuasion there as well. That and if you can probably think of DJs have been known to do this over the years, where if they play the same song over and over again, people start to like it. This is called the mere exposure effect in psychology. And your friends do this to you as well, because they play the music that they like. If you've ever been stuck in a long car ride with a friend who is insistent on playing their music that they like, you can very well start off hating the music, and by the end of the trip, you've actually become quite fond of it. And so there is a sense in which we are inclined to like the things that our friends like. And there's another reason for that as well, which is that when it comes to cultural artifacts like music and books and movies and art, even poetry, there's a certain amount of the enjoyment that we get from it is our own individual consumption. But also we enjoy talking about it with other people, right?
Yes.
So when you think about what is culture, one way to think about culture is as a set of shared references. That the point of culture is not for me to love the Mona Lisa. The point of culture is for us to both recognize that we recognize the Mona Lisa, and this is something that we can share and something that we can talk about and something that contributes to our sense of identity that excludes other people who don't know about the Mona Lisa. And this is true at even a very sort of micro level, where if you think about contemporary music and the sense of identification that people get from liking things that are obscure, it's not about being different to everyone else. It's about being similar to a very small group of people who you happen to care about. Right? So there are these very powerful cross channels happening when we decide what to like. And so in that sense, I think that we are very much influenced by our friends. And so for both these reasons, that you're only exposed to a small number of possible things in the world, and that the things that you're choosing between, when you're making those choices, you care almost as much about the sharing aspect of a consumption event as the consumption event itself. Think about TV series.
But this
everybody wants
be
to watch
playing a role in your music lab, no?
I don't think that. I think in Music Lab, it's most of the effect is just the informational effect, right? That there's probably very little direct peer pressure, as you might call it.
These are anonymous.
And that's because Music Lab was a very short time scale, right? All the things that people are coming in and participating for a few minutes or an hour at most. And on that time scale, you can't really be convinced of things. And you're not even interacting with these people in any sort of social way. So I think that Music Lab is actually a very, very weak signal, right? That the world is much, that to the extent that we can get cumulative advantage out of Music Lab, to the extent that we can show this inequality and unpredictability, I think the real world is much, much stronger. The inequality and unpredictability that we should expect to see in the real world is much greater than we were able to show in Music Lab, because these other forces are much more powerful. So in some sense,
that's
it's
what
almost
I
a limiting case.
I think this
right?
is what my takeaway was, that I felt that, because this is really very pure.
And
It's
if you
really
can,
a very pure
if you can
setting.
get this effect out of a little tiny weak
Yes.
signal, then it's going to be actually much bigger in real cultural markets.
Yes, yes. Also, more generally, what would you see as the more interesting challenges, you know, as we move in this intersection of social science, information science?
Yeah. Well, I think there's a few things that I'm excited about. One is that, you know, as vast as the data is that we have available to us today, it also suffers from some serious limitations, right? So one is that, you know, a lot of the things that economists and sociologists care about, those sort of behaviors that we care about, have not been instrumented in a way that allows us to measure them on this sort of scale. So if you think about a site like Facebook, you know, it's incredible in its scale, but the scope of behavior that it's able to capture is pretty limited, right? That, you know, you can clicks, likes, comments, and you could well ask, okay, that's fine, but, you know, how about for economically significant decisions? Like, there's nothing on Facebook about, you know, how do people invest their retirement, or, how do they, decide when to move cities, or, the sort of big consequential decisions that people make in their lives. It would be difficult to extract that kind of evidence from a site like Facebook. And so there's a lot of work to be done in integrating data that comes from other kinds of sources. And so, if you think about, you know, Facebook has great network data, you know, Microsoft and Google have wonderful search data, Twitter has a lot of interesting data about, you know, information spreading, sort of through the media ecosystem. Other sites have a lot of information about what people are consuming. You know, e-commerce sites have information about what people are buying. Administrative records have lots of information about where people live and what they pay for their taxes, and how much their electricity bills are. And all of this information is siloed away in very different places, owned by different people who are, in general, disinclined to share it with each other or with social scientists. And so I think that for many of the questions that we're interested in, a key development will be the ability to join these data sets. And this is a very sensitive topic because, of course, you know, the NSA has, you know, generated a lot of attention recently for basically doing exactly this, where they have joined data sets of different types. And the joining of the data gives you greater insight into an individual person than any one set of data on its own might do. And so you have to be very, very careful about how to do this in a, you know, privacy-preserving way. But there's tremendous social value to be unlocked in understanding, you know, how the world works by combining these different types of data. So that's one, I think, big direction that you know, hopefully we can make some progress on in a way that is you know, transparent and has, you know, the public trust in a sense. Like, you know, this is data that has been generated by individual people, and, you know, their rights and sensitivities need to be taken into account when deciding how to use it. But I think that there are actually sort of, you know, there is a positive agenda there. There is a way to solve these sorts of problems, and there's a lot to be gained from doing so. And the second big area that I think is very exciting is pushing forward on these large-scale experiments. That, you know, we've been you know, sort of cobbling these things together for years now, and you know, a lot of researchers use Amazon's Mechanical Turk as a source for recruiting and paying people. And, you know, it's great because a few years ago it didn't exist, and we're able to do things that we couldn't do just a few years ago. But it also suffers from some serious limitations, and I think that building a bigger, better version of Mechanical Turk would unleash a huge amount of creativity among behavioural economists and experimental social scientists in general, in terms of the types of experiments that we can imagine running or conducting. So I think those are two major directions that I think we'll see some important developments over just the next handful of years, and that will be, I think that will get us somewhat closer to answering some of the bigger questions in social science that we care about, rather than, as much as I love studying diffusion on Twitter, like, it's not the most important question in the world.